Hello, today we will learn tracing of Cartesian curves. Rules to trace Cartesian curves. Remember all the rules. By using these we trace the curve. First is the symmetry, even powers of y, then symmetry about x-axis. If we consider the example y square is equal to 4ax, here if we see the powers, power of y is 2 and power of x is 1. Here y having the even powers, therefore symmetry about x-axis. Next, if even powers of x, then symmetry about y-axis. If we see the example, x square is equal to 4ay. Here even powers of x, therefore this is symmetric about y-axis. If we see the curve, this is symmetric about y-axis. That is the shape of the curve on the both sides of y is same. Next, even powers of x and y, therefore symmetry about both x and y axis. If we consider the example, x square plus y square is equal to a square. Here circle, we know the shape of the circle, this is symmetric about both axes. The circle is passing through the origin, therefore this is symmetric about both x and y axis. Next is the if we replace x by minus x and y by minus y simultaneously, if the curve remains unchanged, then there is symmetry in opposite quadrant. If you see the example, xy is equal to c square, if we replace x by minus x and y by minus y, then we got again xy is equal to c square. Therefore, this is symmetry in the opposite quadrant. Replace x by y and y by x simultaneously. If equation remains unchanged, then there is symmetry about the line y is equal to x. If we replace x by minus y and y by minus x simultaneously, if the equation remains unchanged, then there is symmetry about the line y is equal to minus x. This is the first point, symmetry. Second, origin and the intersection with axis. For finding origin and the intersection with the axis, for this we put y is equal to 0, we got all possible values of x. Also, if we put x is equal to 0, then also we got all possible values of y. Then by using this, we got origin and the point of intersection. Next is the tangent at the origin. Equate the lowest degree term to 0. Here, if we consider the example, x square y plus x is equal to 0. Here, lowest degree term is the x. Equate the lowest degree term to 0. Then we got the tangent at the origin. Therefore, here we got x is equal to 0 is the tangent at origin. Now, tangent at any point. If we got any other point than the origin, then we find tangent at that point. Find dy by dx at point xy. If the value of dy by dx at point is equal to 0, then tangent is parallel to x-axis. And second is, if dy by dx at point xy is equal to plus minus infinity, then tangent is parallel to y-axis. Next is the asymptotes. Asymptotes is straight line which touches the curve at infinity. It's called asymptotes of the curve. If we consider the figure 1, and in figure 1 the curve touches to x-axis at the infinity. Here x-axis is the straight line at which curve touches at the infinity. Therefore, our x-axis is the asymptote. Next is the second figure. Here if you see the y-axis, the curve touches as infinity to y-axis. Therefore, here straight line is the y-axis. Therefore, y-axis is the asymptote. Next is, we find the asymptotes parallel to x-axis and parallel to y-axis or itself. For finding asymptotes parallel to x-axis. If the symmetry about y-axis, then we find the asymptote parallel to x-axis. For finding this, we equate the coefficient of highest power of x to 0. Here, if we equate this to 0, then we got the asymptote parallel to x-axis or x-axis itself. Second is asymptote parallel to y-axis. For finding the asymptote parallel to y-axis, either we put denominator equal to 0 or we put the coefficient of highest power of y to 0. Then we got the asymptotes parallel to y-axis or y-axis itself. Next is the region of absence. If the values of y becomes imaginary for a certain set of values of x, say a to b, then curve does not lie in that region. Y becomes imaginary, that is, we find such values of x at which y square is negative. If we consider the example y square is equal to 4x, here y square is negative if we consider the negative values of x, that is, if x is less than 0, then curve does not exist. This is the region of absence. Remember all these 5 points. By using this, we trace the curve.